Hi class, we're going to be looking at chapter 14. So we're starting our evolution section, and this is going to be chapter 14 through 16 that will cover the entire evolution unit. So today we're going to be looking at history of the Earth and kind of looking at our timeline of early Earth, where does life come from, and just kind of looking at the age of the Earth as well. So timeline of early Earth, if you're using the notes packet, you have a spot that you can fill this in. So about 4.5 billion years ago, Earth formed. 4.2 to 4.1 billion years ago, the crust formed. 4.0 billion years ago, comets, meteors, asteroids continued to bombard Earth. And then 3.85 billion years ago, first traces of biochemicals, which would be the things we talked about back in chapter 3. So things that could make life. And then 3.7 billion years ago, the oldest life forms, which are recorded through fossil record. Now, our dates and times of the Earth, these are good estimations. There you might see some other ranges of dates out there for the age of the Earth, and these are dates that have been concluded based on evolutionary theory, beginnings of the Earth, looking at fossil records, looking at radioactive dating of fossil records and such. So where does life come from? This was a big problem back in kind of the early days of humans, of understanding where did life or where does life start. And so there were two main beliefs: spontaneous generation, which said that living things arise from non-living things. And there were some reasons that people believed this at the time. They would notice that there would be grain, and all of a sudden they would see mice coming out of the grain. Well, to their mind at the time, then this moldy grain or this wet grain would produce mice. Obviously now when we look at that, it seems silly to believe that, but at the time they didn't really have a way to see all the processes or notice or observe all the processes that were occurring to allow the mice to come to that spot, to allow baby mice to be born, things like that. And then biogenesis. All living things come from other living things. So these are our two main kind of conflicting ideas of where life came from. So we're going to go through three experiments: Reddy's experiment, Spallanzani's experiment, and Pasteur's experiment. These are all in your book. If you have your notes packet, it gives you page numbers for them all as well. So in our first one, Reddy, he studied between 1626 and 1697. He was an Italian physician and poet. And so he did the experiment, which many of you have already studied in the past, with rotting meat. People thought flies came out of rotting meat. So his idea was that he would take some meat, put it in a sealed jar, some meat, and put it in an open jar, and then some meat and put it in a jar that had a covering that would not allow flies to actually get to the meat, but would allow the smell to come out. So there was allowing of air to go back and forth. And so he realized at this time that basically the eggs were being laid on the meat. The jar that had a closed container had no flies and no maggots. The jar with the completely open container had maggots and flies on the meat, and the jar with the container that had a covering had maggots and flies on the top of that covering, kind of like a cheesecloth or a gauze type covering. These are on page 279 with pictures. Our next scientist that kind of built off of this was 1729 to 1799, Spallanzani. And he was an Italian naturalist, and he looked at microorganisms spontaneously generating from meat broth in open flasks. So this is looking at broth itself and seeing if there are small little living organisms that would be generated out of this broth. Page 280 has a good explanation. See if I have it up here. I don't have it up here. So let me explain this to you a little bit here. I'll draw some pictures for you. Basically, he was looking at some flasks, and he had in here broth. And he had one that was closed, had a closure over it, and he had one that was open. So the broth inside this one as well. And what he noticed is that in the one that was closed, no microorganisms grew. And the one that was open had microorganisms that grew. So his idea was that you can see the broth has no microorganisms that are in it if it is a closed container. So it's not like microorganisms are all of a sudden just popping up out of this broth, this non-living thing. And he was showing here that there were microorganisms that could grow because there were things that were kind of falling into it that were allowing it. It was just giving it a place for these things to grow. So to build off of that, we have Pasteur, and he studied 1822 to 1895. He was a French chemist, and he proved that microorganisms are carried by this dust, not the air. So the dust itself was carrying microorganisms. So he just improved on Spallanzani's experiment, and this is on page 281 in your book. In his experiment, he did some very similar work to what Spallanzani did. He had his flask that was open with broth. He had, instead of it being completely like Spallanzani's, where Spallanzani's just left it open, like this, he actually took a flask that had a curved neck and left it open. And he also had one that was closed just to continue that kind of control experiment. So this one that had the curved flask, what he noticed is, in this one, things grew, right? From that last experiment, we noticed that. In this one, he actually found that there was no growth. And so the purpose of this curved flask was air could get in, but right here, in this curved spot, the dust collected. And so he was trying to prove that the microorganisms were actually on this dust. They were kind of living on this dust, and they couldn't get in because they couldn't go past gravity basically and go back up and fall into the broth. So he showed that there's no growth in that meat broth. Well, what he ended up doing was, after a while, he cut this top off, and so now dust could fall inside, and once he did that, he found that there was growth inside of that flask after he cut that top off. So once he allowed the dust to fall back in, then he noticed that there was growth of organisms. So this was kind of the final proof that spontaneous generation did not happen, and instead biogenesis, life comes from living things, was occurring. So our first organic compounds, if we look then, how does that relate to evolution and the origin of life on Earth? Alexander Oparin, his hypothesis in the 1920s is kind of the most accepted hypothesis. Now, one thing I kind of bring up every time I do this is no one was there. We give good hypotheses, good theories, but no one was there. Now, we can see evolution happening. Evolution is just change over time. We can see that happening among species. So that is not really a debatable thing. We can actually see that occur. However, the process of how life was here, that is something that there's theories that are thrown out. They are tested, and from there we can kind of develop our overall idea of what happened when life was started here on Earth. So his original thought was that the primitive atmosphere had things like this: ammonia, hydrogen as a H2 just as a gas, water, and then carbon-hydrogen compounds in different forms. At high temperatures, these gases could have formed simple organic compounds like amino acids. When the Earth cooled, the water vapor condensed into lakes and seas with the organic compounds within. So again, organic compounds are carbon, hydrogen compounds, and they are things like proteins, carbohydrates, fats. with the help of things like lightning and UV radiation, which was common in that atmosphere. It was a very volatile atmosphere. These organic compounds reacted with each other, forming the macromolecules that are essential to life. So can it really happen? According to scientists Miller and Urey, they can actually produce this theory in a lab up to the final step. So they can set this up in the way that Oparin had described, and they actually get amino acids, ATP, and DNA nucleotides in the end of the experiment. Now from there, those are just things that are needed for life. From there, they can't actually make that next step. The actual life forms. So can it happen up to that final step? Yes. And here's his experiment, or their experiment. So they have this water vapor that forms here, which we said water has to be in the experiment input chamber of some of the atmospheric gases that were believed to have been around at that time. They then allow this kind of lightning chamber or spark chamber. It condenses to form lakes, rivers, pools, kind of, in this experiment. And then here they actually have amino acids, ATP, DNA molecules, but no life. From there, it's not like all of a sudden they have cells that produce life. But they do have this process that Oparin had described. They can create that in a lab. Now, other possibilities, maybe there were small life forms, small single-celled organisms that were on meteors that ended up hitting Earth, and then once those were in these lakes and pools, those cells were able to grow and develop into the life forms we have today. Okay, we'll end at that spot. That will be 14.1 and the information from 14.1.